This chapter is about the convex lens. So why we put the convex lens behind the concave lens? Because it's more complicated. Sometimes it will form real image, okay, but sometimes it will also call the virtual image. Okay, so once again, real image is the image that can be captured by screen, but virtual image is the image that cannot be captured by screen. Okay, so here are some construction rules similar to the concave lens. Convex lens have the similar construction rules. When the lights go parallel to the axis, it will pass through the focus on the other side. And in reverse, if it's passed through the focus on one side, it will become parallel on the other side. So this two rule is a little bit different from the concave lens. But what's the same is the rule number 3. When the lights pass through the optical center, it will just keep going without changing the direction. So one more is the convex lens. We usually will draw it as a symbol. It's a very simple way. So how to draw the light ray? Let's go through the examples below first. So here we require to have found the image of the 5 cm tall object located at 20 cm from the convex lens with the focal length of 7.5 cm. So firstly, we put the principal axis and then put the lens in the middle. So let's look at the axis. Okay, so if 5 cm is 1 square. Okay, so we refer to the scale to draw the focus. And this time we also draw the two focus, which is the double of the 7.5. So that's why which is 15. Okay, so now we put the first object here. We use the rule number 1 to put the light ray, and then the rule number 3 to draw the second light ray. So where is the image? Is the intersection of the reflected ray, so which is on the other side. We call it I1. Okay, so how to write the position of the image? It is about 12 cm away from the opposite side of the object. Okay, so we will write in this way. We won't say left or right. Okay, we will make it very clear it's from the lens on the opposite side or the same size of the object. Okay, this is about 3 cm tall. So then we can come to the part B. Okay, we use the same object, but this time it is closer to the lens, so it's just 5 cm. So I use the blue color here, the object 2. So we will found that okay, the one of the light ray we can just reuse it, and we need to add another light ray using the rule 3. So we want to find the intersection point, but it's not on the right hand side. It's on the left side. So we have to extend the reflected ray backward in order to find the intersection point, which is on the same side as the object. Okay, so we found the image here. We call it I2. So this time the image is located 50 cm away from the lens. So this time how we describe the position? Yes, it is on the same side of the object. Okay, and you can see this time the object is much larger, it's 15 cm tall. So with this diagram, we can observe that when the object is different position, the image will have located in completely different position and even different size. So let's go through the step again. Firstly, we draw the principal axis, and then we will mark the position of the focus and the double focus. And we will use the arrow to represent the object, and then we will find the intersection of the reflected ray. So the intersection point is the object. If it is real on the opposite side, then we use the solid line. If it is virtual, we'll use dotted line and put it on the same side. And finally, we will draw the image with the intersection point, which is the position of the image.